looks like this point right here at S happens at 99 degrees. And then my highest point on my graph appears at R at 103 degrees. There are no other y values that are used on this restricted graph here. So my range, I would show that my range goes from, let's go ahead and write this out. My range is between 99 and 103. I'll list my domain. And my domain was from 0 to 12. Okay, let's take a look at another graph. Okay. So on this graph, again, I have a restricted domain. It's showing that I'm only using certain numbers as I go across. And my range is also restricted. I have a low point and a high point, but you notice there's a difference on this graph. There's a little bit of a gap in here. So on this graph, as I list my domain and range, I'm going to make sure that I show or indicate somehow that I might have a gap. So as I go across the X, let's take a look at the domain first. As I go across the X, I'm starting at -4, and as I come across, all of these values are being used. But when I get to 3, I stop. My graph is not included at 3 on this portion of it. But I jump up and 3 is included on this portion. So 3 still works. 3.5, 4, 5, all of those still work. Still have a value, a y value paired with me. So my domain on this would go from -4 to a +5. However, my range, if we look at the range, again, I'm looking at the y value, my lowest point down here at -2, as I work my way up, I make it to 3, but then I've got this gap here. So I'm going to have to indicate that I have a gap between 3 and 4. Then I start again, and I go from 4 up to 5, and that's where I stop. So in order to indicate my range, again using interval notation, I'm going to show that I'm going from -2 up to 3, and I'm not including 3. 3 is not included, so I'll use the parenthesis there. And then I'm going to jump up to 4 and go to 5. And that will represent my range. Okay, this particular graph is a very good example of what we call a piecewise graph, because it's in pieces. So I'm going to take a little bit of a time right now to go over some piecewise graphs with you that you can kind of get the hang of. And show you what so piecewise graphs. So you already have your basic graphs and you know how to work with those. But now let's look at piecewise graphs. With a piecewise graph, it's going to be listed in pieces because different sections will have different parts. And I'm going to take some, hopefully, basic graphs that are familiar to you. And just tell you that, first of all, part of this graph is going to be an absolute value graph. And the absolute value graph is the graph we'll use if our x values are between -1 and a +1. Then I'm going to do the square root of x if my x values are between 1 and 4. So now in order to graph this, what we will be doing is taking each little section at a time, piece at a time, piecewise graphs. So absolute value, you'll remember your basic equations. We have a V-shaped graph centered at the origin. And our x values that we're graphing here will be -1 up to a +1. And I can take x values in this interval here, plug it into my equation to get the basic graph if you're not familiar with it. So for example, if I took 0 and plugged it in here, I would get a 0. If I took the -1 and plugged it in here, -1, the absolute value of -1 is a +1. If I take the +1 and plug it in, you get a +1. This absolute value graph is what I see then between -1 and 1. Now, as I continue, let's go ahead and figure out what happens up here in this range up here. From 1 to 4, it says that I need to jump and start using this equation. So when I take 1, now 1 is not going to go in there. You'll notice that it's greater than 1. So I'm not going to put the 1 in there quite yet. I'm going to leave it alone. Let's take a 2. What happens at 2? When I put a 2 in here, I have the square root of 2. Hopefully you're familiar with that, but we've got 2 would be 1.7. If not, put it on your calculator and you can kind of see where you should be at. I'm going to jump up to 4. The absolute value, or I'm sorry, the square root of 4 is at 2. And you probably remember, go back to your basic graph, that the radical function is going to kind of curve up this way. Now, at 1, I would be at 1, we'll start it there. So I kind of have this weird little check mark going on. I've got an absolute value between -1 and 1, and then I've got the radical function from 1 up to 4. And you notice there's no gap in this one. It's like the first example we looked at. There's no gap in it. When we are able to draw along without a gap, we're going to call these continuous. These are continuous functions. There are piecewise graphs that are not continuous. We call them discontinuous. And let's look at one of those. Let's take x squared if x is less than 2. And we'll do, let's just take a very simple one that you'll be familiar with. If x is greater than or equal to 3. We'll start it at 3. Okay, so let's go ahead and take a look at this graph. Some basic graphs that I said you'd need to be familiar with. So the first one is a quadratic, centered at the origin, and so we'll put in our quadratic here at -1, -1 squared is 1, +1 squared is 1, -2 squared, 4. This one says we're going to go all the way up to 2, but not include 2. So to show that, I'm going to put an open circle there and show that this section of my graph will be a parabola that looks like that. Then, when I get to 3, what I'm going to be doing is graphing just y equals x. So at 3, I'm up here at 3. At 4, I'm at 4. And again, I'm hoping that you're familiar, obviously, with this graph. And that one will continue that direction. This one continues, and we'll show that with an arrow that way. Piecewise graph. Now you notice though that I cannot just draw all in one movement over this whole graph. I have to pick up my pencil or my pen and jump to here. This is a discontinuous graph, but an example of a piecewise graph. Okay, your teacher will have an assignment for you to go over domain and range with graphs and some problems with some piecewise graphs.